In this problem, we're being asked to integrate x plus 2 over x squared plus x from 1 to e. Now, in order to integrate this, we need to think about what integration technique would work best. We might initially, as usual, be inclined to choose u substitution, so maybe you let u be x squared plus x, our denominator. If that were the case, the derivative would be 2x plus 1. Do you have 2x plus 1, the derivative, in the problem? Well, not really, right? I could probably finesse it a little bit, maybe get a 2 there, but the problem is that's still not a 1. Right? There's some conflicts. So instead, what I should recognize is that this can be factored. Okay, this is a rational function right here, and the denominator can be factored. So instead, I should have initially been thinking about probably doing a partial fraction decomposition. So let's go ahead and show that over here. If I were to do this partial fraction decomposition, I know I would be integrating 1 to e, and then the denominator, remember, this can split up into x times x plus 1. You factor out an x, we're left with x plus 1. Therefore, when we do the partial fractions, we would get x as one denominator in the fraction, and then we'll get another fraction with the denominator x plus 1. And since these are both linear, right, power 1, and they're non-repeating, there's no squared or cubed or something in those terms, we would get just a constant up above, right? So a over x plus b over x plus 1. So now our goal is to integrate this. How are we going to find our a plus b? Following the usual procedure, we'll go ahead and create a common denominator. So here, we want to get x squared plus x. We almost have that here. We just have to get the common denominator to add these two. So what we see is x plus 2 over x squared plus x would equal a times x plus 1. And then b times the x, and all of those would be over now the common denominator, right? This and this are equivalent. So if we have a common denominator, that means that the numerators must also be equal, right? If you have a fraction and the denominators are the same, then the numerators must also be the same. So I'm trying to solve this equation. In order to do this, we have two techniques we could use. We either do the Heaviside cover-up method or we do kind of a mirroring technique. I'm going to use the Heaviside cover-up method here. So we'll let x equal, in this case, what would be a good choice? Well, -1 would make a good choice to cancel out this, and 0 would be a good choice to cancel out this term. So maybe I let x be -1, and then I'll also choose x to be 0. We'll see what we get when we do that, okay? So when x is -1, like we said, this term would cancel out. You would be left with -2 plus 1, which is 1, gone, plus b times -1. That would be negative b. Therefore, b would be -1. Okay, so we've got a b value. Now when x is 0, this term goes away. You get 0 plus 2, which is 2 on the left-hand side. A times 0 plus 1, which is a times 1, or just a. Okay, a is 2. So knowing b is -1, a is 2, we go back and plug those in for here and here. Let's rewrite this integral. We get 1 to e of a over x plus, which is really minus, right? Because b is a -1 over x plus 1 dx. Now we'll go ahead and integrate this. Remember, both of these fit the form of the natural log rule. So remember, the derivative of natural log is 1 over x. So the integral of 1 over x would be natural log absolute value of x. Here we get 2 ln absolute value of x for the first term, minus natural log of x plus 1 for our second term. Note that this second portion technically requires a u sub because the denominator is a different value than just x. However, the derivative is 1, right? Derivative of x plus 1 is 1. And so I can kind of do the u sub in my head. There's not really a need for us to work it all the way out. Now from here, we just have to evaluate 1 to e. So plug in our top bound minus bottom bound. Let's go ahead and do this. When I plug in top bound, I get 2 ln e minus ln e plus 1. And then when I plug in my bottom bound, I get 2 ln of 1 minus ln 1 plus 1, which is 2. So let's think about this. We know that ln of e is 1 using our log properties. ln of 1 we also should know is 0. And therefore, what do we get? Well, we get 2 times 1, so 2, minus ln e plus 1, minus 2 times 0, that goes away, minus minus plus ln of 2. Perfect. Note that from here to here, I dropped the absolute values because these terms are all positive. One final step we could also do on this if you wanted to was to combine these logs together. So using log properties, we would have 2, this minus this. Subtraction of logs turns into division. So I would have plus natural log of 2 divided by, turns to division, e plus 1. That would also be a possible answer choice for us.